Okay, so 5.5 deals with inequalities in one triangle. So first we're going to look at the angle-side relationships. If two sides of a triangle are not congruent, then the larger angle is opposite the longer side. So here we have side AB is greater than side BC. What angle is opposite of side AB?
AC. Oh.
What angle?
BC.
Angle.
Oh, C.
C.
I was like,
Angle C. So angle C is opposite of AB, and what angle is opposite of BC?
A.
Angle A. So therefore, angle C is going to be greater than angle A, which is right here. The same thing applies for the converse. If two angles of a triangle are not congruent, then the longer side is opposite the larger angle. So here we have angle Z is greater than angle Y. What side is opposite angle Z? What side is opposite of angle Z? XY. What side is opposite angle Y? XZ. So XY is going to be greater than XZ, which is right here. Now we're going to do some examples. So write the angles in order from smallest to largest. So what's given are the sides. So first we'll write the sides from smallest to largest. So what's the smallest side?
17.2.
17.2, which corresponds to GH. What angle is opposite of GH?
F.
Angle F. What's our second shortest side?
19.6.
19.6, which is talking about what side?
H.
FG. So we're looking at side FG. What's opposite of FG?
H.
Angle H. And what's our longest side?
FH.
FH. And what angle is opposite of FH?
G.
Angle G.
So that means F is the small.
So F is the smallest, so we go from F, then H, then G. So
it would be like G is is greater than F. G is greater than H.
yeah, so if we're listing this from smallest to largest, we start with F, then we go to H, and then we go to G. So our answer would be angle F, angle H, then angle G. Let's do another example. Write the side lengths from shortest to longest. So here it gives us two angles. How do we find the third angle?
By adding. You add them up and subtract one.
So what's 60 plus 72? 132. So we would do 180 minus 132, which gives us 48. So this angle would be 48 degrees.
You just roasted yourself.
I don't care when I got it right.
So we start with the smallest and then go to the largest. So what is our smallest angle?
Oh wait, no. Where's my 40?
Angle R. So what side is opposite of angle R? PQ. What's our second smallest angle? Angle P. What side's opposite angle P? QR. And what's our largest angle? Angle Q. And what side's opposite angle Q? PR. So if we're listing these from shortest to longest, what's our first? What's the smallest, the shortest side? PQ. Then what's next?
QR, PR.
Then QR. Then PR. Thank you. So that's our answer.
4
So this one's giving us the angles first. So we're using the angles, the measures that was given to us for the angles, in order to find which one's the shortest, second shortest, and the longest side. In the other example, it gave us the side lengths, so we knew which side was the shortest, and we had to find what was the smallest angle. So if we go back to the example before, it was giving us the side lengths. This one's giving us the angles. Let's do another example. Write the angles in order from smallest to largest. So we're going to start with the smallest and go to the largest. What is our shortest side we have here?
AC.
AC. And what angle is opposite of AC? Angle B. So angle B is going to be our smallest angle. What's our second shortest side?
C.
CB. And what angle is opposite of CB?
A.
Angle A. So that's our second smallest side. And what's the largest side? AB. And what angle is opposite of AB?
C.
Angle C. So that's going to be our largest angle. So if we're writing these angles from smallest to largest, what order would we write them in? Angle B, angle A, and angle C. Perfect. Okay, write the side lengths from shortest to longest. So it gave us two angles of this triangle. How do we find the third?
So you just equal it all to 180. Just add 90 to and minus it.
So 180 minus 112, and we get 68. So we start with the smallest, and then we're going to go to the largest. So what is our smallest angle we have here?
Oh.
Angle D, what side is opposite of angle D? EF. What is our second smallest angle?
DF.
Angle E. And what side? DF is opposite of angle E. And then what's our largest angle? Angle F. Remember, this box means that it's 90 degrees. So 90 degrees would be our largest angle. And what side's opposite of angle F? DE. So how would we write from shortest to longest? EF, DF, then DE. Perfect. Yes.
Why do you not have to write like the line above it? Like for EF, why don't you have the line above
I mean, yeah, you do, but like she isn't doing it, right?
Yeah, you could write it. Remember when we're talking about like the length of it, you don't have to write the line above it.
it? Okay.
When do you have to do it? Like,
If I was saying that like EF,
is greater than whatever, you have to put the line over it?
yes. Or if I was saying that it was like congruent to
Yeah.
AB, then I would have to put the line.
Alright. Whenever you want to.
Yes. Okay, a triangle is formed by 3 segments, but not every set of 3 segments can form a triangle. So segments with the length of 7, 4, and 4 can form a triangle, but segments with the length of 7, 3, and 3 cannot form a triangle. So a certain relationship must exist amongst the lengths of 3 segments in order for them to form a triangle. And that relationship is that the sum of any 2 side lengths of a triangle has to be greater than the third side. So AB, if we add these 2 sides together, AB plus BC, it has to be greater than AC. If we add BC and AC, it has to be greater than the third side, AB. And same for the last one. If we add AC and AB, it has to be greater than BC. So now let's look at some examples. Tell whether the triangle can have sides with the given lengths. Explain. So a trick in order to do these is if you take the two smallest ones and add those together first, you have to see if they're bigger than the third side. So what are our two smallest sides here?
7.
So 7 plus 10 is equal to 17. Is 17 greater than 19? No. So would this be 3 lengths of a triangle? No. And our reason would be because 7 plus 10 is not greater than, so we could put it's less than 19. Tell whether the triangle can have the sides with the given lengths. Explain. So what are our two smallest here? 2.3 plus 3.1 is equal to 5.4. Is 5.4 greater than 4.6? Yes. So this works. So this is greater than 4.6. Let's check our next two. So what are two other sides we can add? 2.3 plus 4.6. And what do we get? 6.9. Is that greater than, what's our third side? 3.1?
Yeah.
Yes. And what's our last two that we need to check? 3.1 plus 4.6. And what do we get? 7.7. Is that greater than 2.3?
Yeah.
Yes. So our answer here would be yes. These three sides can be the sides of our triangle.
Can you explain?
Right here, what we did, all this work, is our explanation. So remember, if something's true, you need to prove that it's true by using every example. But if it's false, all you need is one counterexample. That's why for the last one, all we had to do was just one. But this one, we had to test all three sides in order to prove that it's true. Tell whether the triangle can have sides with the given lengths. Explain. So our sides are x plus 6, x minus 1, and 3x when x is equal to 4. What do we do first here? Plug in 4. So what is 4 plus 6? 10. What's 4 minus 1? 3. And what's 3 times 4? 12. So first, let's take our two smallest. 10 plus 3 is equal to 13. Is that greater than 12?
Yeah.
Yes. So now let's add 10 plus 12. 22. Is that greater than 3? Yep, so that works. And then we can add 12 plus 3. And we get 15. Is that greater than 10?
Mm-hmm.
Yes. So can these three be the lengths of a triangle?
Yeah.
Yes. Tell whether a triangle can have sides with the lengths 2.7, 3.5, and 9.8. So first let's add the two smallest. So 2.7 plus 3.5 is what? 6.2. Is 6.2 greater than 9.8?
No.
No. So can these three lengths be the sides of a triangle?
No.
No. And our reason is because 2.7 plus 3.5 is less than 9.8. It has to be greater than the third side. So since these two added together are less than the third side, it can't be three sides of a triangle. So we can't have a triangle with the lengths of 2.7, 3.5, and 9.8. Just doesn't work. The lengths of two sides of a triangle are 8 inches and 13 inches. Find the range of possible lengths for the third side. So for this one, we're going to need a range. So we need something that x is greater than and something that x is less than. In order to find our number that's going to go to the left, we have to subtract the two numbers that are given to us. So we subtract 13 and 8. It's important that you write the bigger number first because you don't want a negative number. You can't have a side length that's negative. So we'll do 13 minus 8. What do we get? 5. So 5 is going to be our lowest number that we can get here. So x has to be something greater than 5.
And then you add 8 and 13.
And then we add 8 and 13 to find our higher number.
It's 21.
So 8 plus 13 is 21. Perfect.
And then
So this is our answer. X is greater than 5 and less than 21. So if we plugged in any number in between 5 and 21 and added them together and see if it's greater than the third side, it would work. So what's a number in between 5 and 21 that we can try? 10. So if we have a triangle with 8, 13, and 10, what are our two smallest sides here? 8 plus 10, 18, which is greater than 13, so that works. What's another two sides that we can add together? 8 and 13, which is 21. Is that greater than 10?
Yeah.
Yep. And what's our last two that we can add together? 10 and 13, which is 23. Is that greater than 8?
Yeah.
Yep. So 10 works. Yes.
Do you have to show all that work if it's just asking for the range?
All I need to see is this.
Oh, okay.
Okay, last example. The lengths of two sides of a triangle are 22 inches and 17 inches. Find the range of possible lengths. So we're going to have x is going to be greater than a number and it's going to be less than a number. So we need a number to the left and a number to the right. How do we find our number to the left?
you minus 22 and 17.
So 22 minus 17, and what do we get? 5.
Yeah. And then you add it, it's 39. Right?
So then we add them to find our number to the right, and we get 39. So our answer is x is greater than 5 and less than 39. And that's 5.5.